here's going to be my 2D motion quick review, if I can. For 2D motion, we're really looking at kind of two major types of problems. If we're talking about the ones that I want you to nail for this unit. We're talking about things that get launched at an angle, hit somewhere else. We're talking about things that roll off, launch off, fly off, shot off, thrown off horizontally. And then land somewhere else. Those are my two major things. So as long as we can handle how to approach these two types of problems, you should be good to go. So that's what this video is going to be about. Rather than watch me do a bunch of things like write these tables on the board, I paused. Now, I'm assuming you know how to break down any vector that's at an angle. So velocity, displacement, anything that's not perfectly up and down, left and right, we want to break it down into those two components. I'm pretty sure I've seen every one of you do that. We've worked on that. Now the question is, what do we do with those? I think that's an important piece. I'm going to talk about this top setup here, where there are two primary locations that we're going to be really studying for preparation for this test. Either the very top, where it's maximum height, where people want to know how high did it go, and the farthest point where it lands, how far did it go. So for this, what I want to encourage you to do is always take these two and plug them in. I'm going to plug these two in both of these tables for both of these types of problems, and I'm going to put the accelerations in. Because once we have all of that there, we should be in a good spot. So the vertical initial velocity goes here. It's also here. 16.9 meters per second, it's positive, it's going up at the start. This 36.25, I'm going to put in the initial horizontal. Units will be meters per second for all of those. That's critical. For accelerations, because it's launched and we're just talking about in the air, projectile motion follows a parabolic curve because gravity's pulling down and we're ignoring anything air resistance-wise horizontally. So that means there's no acceleration horizontally, no air resistance, no force changing that acceleration. We'll learn that more about that next unit. But gravity is pulling down the whole time. So I can put 0 and negative 9.8 in both of those. So now all we need is just one other piece of information to be able to start making things happen. With only two pieces, we can't go any further. For a problem asking how high up in the air it goes, the key thing for this is that at this moment, its velocity is exclusively horizontal. It stopped going up, it has yet to start coming down, so that moment is when its velocity vertically is 0. So if I'm just solving for how high did something go, I can put this, in fact, let me make this my red, because this is important. This is the trick to this problem. Then we pick the equation that ignores time. We can do VF squared equals V naught squared plus 2A delta x. Solve for that delta x, and you get your answer for how high. The tricks for how far, essentially when a problem wants to know, well, how far does this thing go? That question is more readily answered by understanding the fact that it launched and came all the way back down. So, and now it's going down, its velocity looks something like this, and it's no longer a 0 velocity, but the 0 is the vertical displacement because it went up and came back down. So if I subtract my final displacement from position from my initial, I get a displacement of 0. That's critical. Because then all of a sudden, actually let me make that also in red. This is to answer the question, how far? Then what you do is you solve for time. You get that time by doing this equation, our delta x equals V naught t plus 1/2 AT squared. Once you get time, you can use that same equation again to solve for that horizontal displacement. So those are kind of the keys for problems like this where it's launching. You got to break the vector down into the vertical and horizontal components. You got to make it happen. And then the only other type of question I might ask is, well, how fast is it going when it slams to the ground or hits this or hits that? If you're trying to figure out that problem, then that is going to be, let me switch to a darker piece here. To get that, I need the vertical and the horizontal final velocities to solve for this total vector sum. So I need to get these two, and then I put them in a squared plus b squared equals c squared to get the total velocity, final velocity. So that's the only other type of question that I think I could imagine. At that point, you will have filled this entire table, and look at you, you've got it all. Nice moves. So that's for doing any problem like this, where it's launching at an angle, and it's either asking how high, or how far, or how long it was in the air. That's even easier because it's only one part of that step. Or if it wants to know how fast it's going to the end, then you need to go for how fast does it, whatever that problem is. So that's our launch. If you can nail these two, if you can nail this process, the rest should feel pretty good. Let's just show how good that'll feel if you do this. If it's only a horizontal velocity, let's say 10 meters per second, and it's a height of a 5-meter table. That's a wicked tall table, but for now we'll just leave it at that. So 10 meters per second, because this is only horizontal, the key is that these problems will have the word horizontal in them and give you that like cue. It's launched horizontally, thrown horizontally, rolls off a table, slides off a cliff horizontally, skier pops a little landing horizontally, all those things. Horizontal tells you that this velocity goes in just the initial horizontal, and there is no vertical velocity because everything's only going horizontal. That's clutch, because then we put our accelerations in like we know. Now we just need one more piece of information to make anything happen. Likely it'll be a height. Maybe it'll give you more than that. But for this case, the height is here. So I'm considering it's dropping. I like to make up and to the right positive. So this thing is dropping is the negative. So I'll make this -5 meters for all of our units' sake. Now I can solve for time. Now I can do anything once I solve for that time. Same way I did up here. Once I have that time, doors are open. I could solve for this velocity. I could solve for this distance, how far does it go? I could solve for the total velocity, because in the end this thing's going down at an angle, which means I want you to think about anything that's moving at an angle to be looked at like this. Two different parts, components. We get this vertical, or this horizontal, you get this vertical, Pythagorean theorem, a squared plus b squared equals c squared, and you're off to the races to get a final total velocity. So we can do all these different things. This is kind of my quick review for how to get things set up, and away we go. And so my hope is that that's helpful. Send me an email if you got questions and it doesn't quite do justice to what you need. Thank you.